All right, so I wanted to give you one that wasn't like the other two from your homework, okay? In this case, we have a negative and then an odd in, but in your homework, I believe you had an even in that was positive and then an odd in that was positive, okay? And so you should have gotten these two graphs if you graphed them correctly, okay? And depending on what numbers you had, like if you did just like 0, 1, 2, you would have had something that shooted off a little bit. And then if you did, -2, -1, 0, 1, and 2, you would have had something that looked like this, kind of like a cubit. Okay? You would have been able to answer all your questions after that, such as your domain and range. Okay? So when n is positive, your domain is from 0 to infinity. Your range is from 0 to infinity. Okay, included, because you can plug in 0 and get a 0 back. You have an intercept at 0, 0. You'll only have right end behavior because there is no left. It stops at 0. It's continuous on the entire interval 0 to infinity, and it's increasing the entire time. And number 6, when n is odd, okay, you're going to have functions that look similar to this one, where your domain is negative infinity to infinity, just like your range. Your intercept is 0, 0. You will have left end and right end behavior similar to a cubic. It's continuous, and it's increasing the entire time. Okay? So, do be aware that for those types, okay, they will have similar features. Okay? So unlike how I gave you a table for your power functions, when n is positive or n is odd and a is positive and so on and so forth, you can kind of make your own table using these examples here. Okay? Questions?
I just did it with the graph. Like I went to go plug them in and it just didn't work right.
Okay? Well, say you picked one. Would you plug in 1 for x, and then 3/4 is your exponent? 3/4 is just a fraction, 3 divided by 4. So you want to make sure that you include parentheses around that, so that the calculator knows you're raising to 3/4 power, and it'll get you your number output. Same thing here. You plug in 2, you raise it to the 5/3, type it in just as a regular fraction.
I just did it on Tinder when I got it.
Might be running into the same thing. You got examples here, so like I said, you can make your own type of table, type of chart to kind of, just as a reference, kind of like the one that I gave you before, to help you, okay? If you go and look at your notes here, we can now fill this in. We call that x raised to 1 over n indicates the nth root of x, and p over n, where p over n is in the simplest form, indicates the nth root of x to the p. If n is even, the domain must be restricted to non-negative values. Non-negative values are from 0 to infinity. Okay? If you look at the example from your homework, if n is an even number, like it was in number 5 from your homework, you're restricted to just the non-negative values. You guys see that right there? Is 0 included? Yes, it is. Okay? So, if n is even, the domain is 0 to infinity, included. And if n is odd, negative infinity to infinity. Look at number 6. N was odd. It was a 3. Our domain was from negative infinity to infinity. You see that? Lastly, it says if n is negative, like our problem of the day. Negative infinity to 0. Is 0 included? Think back to the problem of the day. There was an asymptote at 0.
No.
So it's not included. But it's everything else but 0. So those are your respective domains for n when it's a rational exponent. Okay?
Is there a reason why didn't you put parentheses in the second one? Oh.
No, I got it. All right. Thank you. Okay? So you can use those examples here in these types of situations. All right? To go along with that, with your more specific radical equations, okay? Remember that exponential form, p to the n, can be written in radical form, where your denominator is the root, and your numerator goes underneath the square root, or underneath the root, okay? And a radical function is a function that can be written in that form, where n and p are positive numbers greater than 1, and have no common factors. Now realize that if n were 1, do we have anything as a first root?
No.
No, the smallest root that we can have is a 2, a square root. And you guys know they're not going to put a 2 to represent square root. You guys know that, right? It's just the square root symbol. All right, but cube root, fourth root, they'll put a small number as the index there. Okay? So, we kind of already talked about this before. If n is even, if the denominator is even, what's going to be the domain? It's going to be 0 to infinity. Is 0 going to be included? Yes. And if it's odd, it's going to be negative infinity to infinity. Now, n cannot be negative when you're dealing with square roots here, because not so much can't take the square root of a negative number. If n is negative, that means we have a negative root, like the negative square root of a number. Is there any such thing like that? No. So that's why there isn't an option there.
You can like call it like the I, like naturally.
That's if a negative's underneath an even root. Okay? But still, we wouldn't graph that on a real coordinate plane. All right? So let's look at some special features here. Again, if n is even, we know our domain and our range is going to be from 0 to infinity. We'll have an x and y intercept is 0, 0. It's continuous on that interval from 0 to infinity. No symmetry, because it's only half. It's increasing the entire time. You do have an absolute minimum, though, at 0, 0. With endpoints, you can only have absolute maxes or mins. Okay? You can never have relative maxes or mins at an endpoint. So in this case, since 0, 0 is the lowest value for this function, we have an absolute minimum of 0, 0, and only right-end behavior. And with n being odd, you see its respective features there. There's no extrema. It's increasing the entire time, and we do have left and right-end behavior.
So it's basically like a cubic.
Exactly. Very similar to a cubic. Questions? What we're going to do is we're going to graph one of these radical functions, and then we're going to move on to radical equations, okay? So you have your choice. Which one?
First one.
I heard.
Second one.
I heard a vote. So the second one, y'all want to do the second one?
Yes.
So let's go ahead and let's complete this table. Let's go ahead and complete the table. 2 minutes. To do the fifth root, realize you have 1/2 fifth root of 3x minus 4. So that means we're going to do 1 minus 1 divided by 2. Or you can do 0.5. Doesn't matter. To do the fifth root in your calculator, you press 5. Then you go to math. Then you go down to option 5, which has an x and then a root.
And it makes your life easy.
And it basically gives you the fifth root. So then this will pop up, or if you have one of those other ones, the 5 will pop up as the index. And you'll type in 3x minus 4. Okay? So again, you'll type in 1 divided by 2, 5. You click the math button and go down to option 5. And click enter. Did you guys get the x with the root? Good stuff. Now type in the rest of the function.
You just click 5.
Yeah, it's the function.
So 1 over 2 is supposed to be that.
No. I have to do my backwards. Yeah, if yours is like mine where it pops into the index, you'll probably have to do the fifth root first and then go back and make sure there's a 0.5 there, or 1/2 there. But it cannot be in the exponent, because if it is, it's gonna read something completely different. Was it +4 or -4?
We can't just do the radical part first and then multiply it by 1/2.
Yep, you can do that. You can do the radical part first and then multiply by 1/2 at the end. But get the rest of my table. Get the rest of my table. -2, you got negative point. -1, you got negative point. For 0, you got negative point. For 1, you got negative point. For 2, you got point. 5 what? And then for 3, you got point. So when you plot these, you have something very similar to that odd power function, or when n is odd, like that other screen, okay? And on the side, your domain and range are the same. It is -infinity to infinity. So your domain and range, -infinity to infinity. Our end behavior, very similar to a cubit. The limit as x approaches positive infinity. What's happening to your y's?
Increasing.
Going to infinity. And your left end behavior as x approaches -infinity. You're going towards -infinity. Again, very similar to a cubic. It is odd, so cubics, fifth roots, seventh roots, so on and so forth have similar end behavior. Am I continuous? From where to where? All real numbers.
You need to write all numbers for each draw the same.
And then, is it increasing or decreasing?
Increasing.
From where to where? Now for your intercepts. This is a good review of Unit 1. How do you find your y-intercepts?
Y equals.
You plug in 0 for x. So to find our y-intercept, I need to plug in 0 for x. 3 times 0 is?
0.
And then -4 is going to be a?
So wouldn't it just be the 0 answer
It would be the 0 answer for that, because when we plugged in 0 for x, this is what we got, correct?
for this? Yes.
So my y-intercept is 0, comma, -0.66. How do I find my x-intercept? You plug in 0 for y. So I have 0 equals 1/2 the fifth root of 3x minus 4.
So would be times 2.
Mm-hmm.
And then
Oh, wait. I gotta get x by itself. So to get rid of the 1/2, I'm gonna multiply both sides by 2. 0 times 2 is 0.
And then you
fifth root of both sides.
not fifth root it,
It's a
you,
power.
yeah, to the power of 5. I don't know.
You raise everything to the power of 5. Raising everything to the power of 5 is gonna get rid of your fifth root. Just like if it was a square root, squaring both sides will get rid of your square root. So you have 0 equals 3x minus 4. Add 4
Divide by
and divide by 3.
So it'd be 4 over 3, 0.
Exactly. That's how you find x and y intercepts. A nice review from the first unit. Solving radical equations. No more of the simple ones, such as 3 equals the square root of x. No more of those. Those are the easier ones, okay? No more of these, okay? We're beyond those. So, same rules still apply though, okay? The trick is when you're solving radical equations, you want to make sure to get the radical by itself, okay? So, is the radical by itself on one side?
No.
No. How do I get it by itself?
Add 3.
You need to add 3. Now when I add 3, this does not become 5x. This becomes what?
2x plus 3 equals the square root.
And now that I have the square root by itself on one side, you square it. Because I'm trying to get rid of the square root. Yes. This over here does not mean 4x squared plus 9. You have to FOIL this left side. Okay? So 2x times 2x is
4x.
outer 2x times 3.
6x.
Inner 2x times 3.
6x. Plus
3 times 3 is 9. Combine your like terms and you get what?
4x squared plus 12x plus 9 equals.
Because when you square a square root, the root goes away. Now what do you think I'm going to do here?
Combine like terms by moving the 28x and 29 over to the left.
So I'm going to move everything over. So I have 4x squared minus 16x minus 20 equals 0. And what is this?
Quadratic.
A quadratic that we did last week.
So, the factor.
You can take out a 4. 4 is known as your what?
Greatest common factor.
Greatest common factor. You're looking for two numbers that multiply to give you negative 5, add together to give you negative 4.
X plus 1, x minus 5.
So negative 5 and positive 1. Set what equal to 0?
X minus 5 equals 1.
And 4. So you're going to set 4, x minus 5, and x plus 1 equal to 0. Okay? It's good to get in the habit of setting that outside factor equal to 0 because if it's an x, that's a 0. That's a solution. But 4 equals 0 is nothing. It doesn't help us out there. X could equal 5 because you add 5 on both sides, or x could equal. Now, I said they could equal. You always want to make sure you do what? Plug them in and check for what type of solutions? Extraneous solutions. So, you need to check because not every time will both numbers work. Plug it into the original equation. So, when I do that, 2 times 5 is 10. 28 times 5. Don't use your calculator here, okay, guys? Try to do this without using your calculator. 0. 140. What's 140 plus 29? Minus 3. You should know your perfect squares at least up through 20 because this is one of them. 13. 13 minus 3, is that 10?
Yes.
So 5 works. Check 1. Sorry. Negative 1. 2 times negative 1 is? 28 times negative 1. Plus 29 is? What's the square root of 1? Is 1 minus 3 negative 2? So they both work. This time. Won't always work. Got to check, you have to check. Let's look at the next one. What's gonna be the first thing I need to do? Subtract the 8. Because I need to get the root by itself. It's not a square root this time, but a cube root. But I got a cube root and then I got something being squared underneath. What am I going to do first? You're going to cube. Because you want to get rid of your root first, or apply your root first, and then deal with your squared afterwards. So we'll have 64 equals x minus 2 squared.
Square root. So that's a perfect expression on square both.
Yep. Even if it wasn't a perfect square, you still want to, not square, but take the
The
square root. Because a square root will cancel out the square. So, square root of 64 is, but not just positive 8, but also
Plus or minus.
negative 8. Remember, in an equation, when you square root both sides or take the even root of both sides, so if it was a 4th root or a 6th root, 8th root, it's always plus or minus. Yes?
When you add that to the plus or minus or plus or minus?
It's going to be, we're going to have 2 solutions. When you add the 2 over, you'll have positive 8 plus 2, and then you'll have negative 8 plus 2 for your 2 solutions for x. So you have 10 and negative 6.
Now we have to input it back and then check which one is going to be working.
Right. We always got to check, so we're going to plug it back into the original.